Start recording. All right, so we were joined by my friend and friend of the class, Kyle Sykes, environmental analyst with Entergy background in environmental engineering, graduate of Mississippi State University here in the Jackson area. Thank you so much for joining us. We're recording this for all of our computer science engineering students in Madison County schools at all of our middle schools, including Shirley Simmons, Old Town, Germantown, Madison Central, Ridgeland, Academic Options Center, and our YouTube channel. So thank you so much for taking some time for us today.
No problem. Glad to help in the way I can.
Yeah, so we've had a chemist, we've had a chemical engineer, and kind of what you do is kind of like the last step of the process when it comes to hazardous waste, and you've got an unbelievable resume when it comes to engineering in that area. But before we get to that, talk a little bit about your educational background, because like we said, you are a graduate of Mississippi State and went to their great engineering program.
Yeah, so I graduated high school. Went to Northeast Louisiana for a year. Thought I wanted to be an occupational therapist. Really didn't jive with it. So I ended up pivoting to Mississippi State, and I graduated with the biological engineering degree with an environmental emphasis. My first job out of school was I was working at a plant where we did nothing but dispose of waste, hazardous, non-hazardous. I did that for about 3 years. Then I moved to Jackson. I was living in Memphis at the time. I moved to Jackson and I started working for the Mississippi Department of Environmental Quality. So I worked there for like 7.5 years, touched just about everything, air, water, waste. Then moved over to Entergy in 2015. My first job at Entergy, I was an environmental analyst, but I worked at the plant sites. So I worked at the plant sites, handled all their day-to-day stuff. 2020, in the middle of COVID, while the world was pivoting, I did a pivot as well. I took another environmental analyst position for the group, and so I am the state lead for air emissions for any plant that generates power in the state of Mississippi.
That's incredible, and that is quite a few. And like we said, we had a chemical engineer last week that talked about the air pollution and how the height of it and the heat of it and how that has to be broken down and the safety of it. And I think you just gave a great example that if people are interested in engineering, it's not just the mechanical side. There's a lot of things that have to happen at the end of the process, because obviously we know engineering is a process, and you do kind of the last thing and the storage of the materials, the disposal of the materials, which is a huge health hazard, and it's part of actually engineering in the government, because it's part of the state government as well.
Correct. Federal government as well too. So I know everybody hears about the EPA. That's the federal side of everything. So yes.
Now, talk a little bit about some of the materials that you've dealt with, because we obviously, I don't think people understand, especially students, how many materials actually touch every single thing that we have, whether we use it, eat it, wear it, drive it, live in it, whatever. There's materials in everything. And it's not always like when you have the raw lumber and then it's put through a plant, you're going to have something left over. That material has to be disposed of or destroyed. So talk a little bit about kind of the materials you deal with and how that process works.
So my first job, I dealt with nothing but waste from schools, from industrial sites, from labs, everything. Whenever there's a process, there's going to be some waste. And so, case in point, we actually did a school clean out one time in the Jackson area. And we came down from Memphis, and it was a bunch of schools that JPS had us coming getting materials. And one of the classes, I'm not going to name the school, but one of the classes I walked into, there was some kids in the class, and we walked in, and I walked into the little lab in the back, and I've seen some of the craziest stuff in that lab. I mean, diethyl ether, that is very explosive. That is a lot of people use it in labs, but when it expires, it forms what's called organic peroxides on the actual lid. So if it forms the organic peroxides on the lid, if you twist that lid, it literally can explode in your hand. Wow. And so we have to do like what was called a high haz stabilization for it. And so basically we had to take it out, put it under a bomb blanket, drill inside of it. And I think it's been a while. I think you neutralize that with sodium amide was water. It's one of them.
Oh,
So
still.
yeah, it's crazy. And I mean, and to bring it back home, one of the jobs I did while I was working there, I went to a Kellogg plant right outside of Memphis in Arkansas. And I'm walking through the Kellogg plant while I'm watching them bag all these different things, and I'm taking out chemicals. That was part of the process of making the cereal. So
That is absolutely insane. So, um, obviously, there's a need for more of these type of engineers because everybody they want to do the mechanical, the electrical because it may be more exciting. But what you do is even more important to not only the health but the safety of people that are using these products.
a lot a lot of people don't understand a lot of the things that come with environmental engineering. You know, waste is just one part of it. I mean, you can deal with water, you can deal with landfills, you can deal with air, you can deal in one part of environmental engineering and stay there literally for 30 years
Wow.
and never touch anything else. I mean, but it's all important.
Yeah, and especially with the growing concern for climate change, the growing concern for pollution, with the whole deal with the electric vehicles. So obviously, the need for this is going to expand.
Correct. And with environmental engineering, we've kind of been on the forefront of a lot of a lot of the things that people are talking about now, whether it's renewables, whether it's the potential for climate change, whether it's electric vehicles. We've been looking at the different impacts that the way we've been trending versus where we're trying to go for years. So it's kind of interesting now that people are interested in kind of what I've been doing for years, and to see the conversations being held across, not only different political arenas, but schools, children. When people hear that I work for energy, they always want to know, they want to talk about renewables and everything else. So I mean, it's interesting and it's cool that I'm actually getting to talk a lot about, what I've done and what we're trying to do.
Yeah, and then I mean, and on top of that, not only is it for the greater good, you're on top of cutting edge technology on top of that because all this, companies are going to try to find ways to save money and also save waste, and that's where environmental engineers come into play because they can come up with a process that does both of those.
I mean, that's correct. We've been people like myself have been pulled into meetings now when different companies or even when governments are going over their business plans, they want to know, hey, well, is there a cost cutting measure that we can try to put into the budget, that's centered around, you
Wow.
know, renewables or waste reduction or anything else. I mean, it's a lot of different things that goes into being an environmental engineer nowadays.
Yeah, and also, and I know you're humble, but you also had a big role down on the oil spill on the Gulf Coast.
Yeah, I did. I worked on the Gulf Coast for about, let me see, they kicked off about 2010. I think my last rotation was about 2013. So about 3 or 4 years. I was part of a task force that represented the state of Mississippi's interest in regards to our stakeholders on the coast for the BP oil impact. I worked with a lot of different organizations, federal, other states, and we walked the beaches. We came up with progression plans on what it looks like for our definition of clean. We were out in the community talking to a lot of different people that were affected by the BP oil spill, the shrimpers, the fishermen, a lot of the restaurants that relied on a lot of the fresh seafood. We had a lot of town hall meetings, and so it was very interesting in regards to doing that. That's probably one of the best projects that I was involved with because I learned a lot about the coast of Mississippi, and I learned a lot about the people, and I think that was probably the best part of that job.
Yeah, and I think that's a great point because unlike other areas of engineering, and I know they're a lot more out in the field than people realize, but an environmental engineer, you're not just cooped up in an office all day. You really get to be out and about. You get to see different parts of land, different areas, and it really is one where if you want to experience that thing where you get to experience nature, this could be a good fit for you.
Well, I mean, it's part of the name, environmental.
Yeah.
You're in the environment. It's. I do a lot of office work, but I can tell you now, I've been in the field a lot as well. One of the most interesting things that I've done outside of the oil spill, I was down in New Orleans maybe a month after Katrina. And I mean, I was in New Orleans where there was nobody on the interstate but me. You didn't see anybody on either side, behind you or in front of you. You're in a major metropolitan city, and you are the only person on the interstate. And I was going around picking up hazardous waste. That's what I
Wow.
was doing.
Well, I mean, and again, just such a huge need. Now before I get to some the students' questions, I do have a couple of things that I wanted to point out. One, I ask all my guests the same thing, and something that and I think I can speak for all teachers that are going to see this later as well, is that especially in engineering, but in any type of field, but in engineering especially, we're all familiar with the engineering design process and how that the basic engineering, but so many times these kids want to they start something and they're like, oh, this is too hard, I quit. How often do engineers of any sort get it right the first time?
Um, I can't speak for everybody, but I can tell you now that I do not get it right the first time every time. It's a process. I would tell students nowadays, when you're in math class, right? So you have your regular problems and you have word problems. And engineering is nothing but a big word problem.
Yeah.
That's it.
Yeah.
That is it. And you may not get it right the first time. You may have to go back and read and comprehend, but engineering is nothing but a really big word problem.
That is a great way to explain it. Now, obviously, we're about the same age, and technology has changed just in the last few years. So, what are some of the technological advances that you've seen in this field? Because obviously, the way you collect data is different than it was 10, 15 years ago. And I think that's important because we're actually doing some assessments now on collecting data because it is such a huge part of any type of scientific field. So, what are some things that you've seen change from then to now?
So I started working in 2004. 2005 was my first job in engineering, and it's 2023. So you're talking about 18 years. The biggest, and it's simple, and when I say it, you're gonna be like, yeah, that makes sense. The biggest piece of technology that has impacted my job is the cell phone because I can now receive data. I can now receive everything at the drop of a hat. My emails come to my phone. I get reports on my phone. I don't have to worry about getting to a laptop. There's a lot of things I can do now from my phone that's instantaneous. So I would say the advent of cell phone technology and integrating it into the workforce,
Yeah.
that has definitely been the biggest. Because my first job, I had a laptop, but I had to wait till I got to the office, or I had a little card I can do work at home or whatever. But now with the advantage of my cell phone, I mean, I'm connected to my laptop. I receive emails on my laptop and my cell phone simultaneously. I can, you know, work from there. I can, get lab reports on my phone. I get a lot of my data every day that's emailed to my phone, and I can, look at the different things that I need to look at. Call somebody. This looks a little off. Can you check on that? And so, cell phone technology.
Yeah, and along those same lines, for anybody that wanted to develop an app, there's a lot of money that could be made in this field for developing an app for environmental engineering because it's like you said, the data is so important, and having that instantaneous reading could be very profitable for the person that wants to develop something like that to improve it.
That's definitely true. That is definitely true.
All right, so I got some questions from the students. We'll get to as many of these as I can. Now this is an interesting one. This is Justin Clerk. He's a senior, and he asked, "What's the weirdest waste you've ever seen?"
Hydrofluoric acid. Hydrofluoric acid will continue to burn until it gets to anything with a calcium in it. So you do not want to get it on your skin because it will burn to your bone.
Wow.
It's very potent. I had some one time, and I didn't realize what it was, and my friend told me, hey, you put that down right quick. And so I put it down, he was like, yeah, that's some bad stuff. We don't really want to just open hand handle it. I mean, I had gloves on and everything, but we had to keep a tube of calcium gluconate with us just in case we were ever exposed to put it on us so we can stop the burning sensation. And I want to add something to that. I was thinking about it. Sodium amide. I was at a job, sodium amide, if you look it up, it is water and air reactive. So how do you neutralize something like that? Great question. So I had it in my hand. I thought it was non-hazardous. I was getting ready to put it in a non-haz. And one of the more experienced field engineers was like, "Hey, no, let me show you what this is." He showed it to me. The only way to neutralize that, you have to take that, put it in a drum of diesel, and then open it up under the diesel so it is not exposed to air or water.
Wow. That just sounds scary. And that's a great segue to our next question. And you did briefly talk about this, but this is Jacayla Page. She's a sophomore. And she asked, do you have to wear any special clothing when you deal with waste?
Yes. So if you're in the field, the minimum you're going to want to have is you want to have some gloves. You're probably going to want to have some steel toe boots. You're going to want to, if you're going in especially if you're in an enclosed area, you're going to want to have a respirator. And a lot of times when we were back at the facility, I actually wore a respirator that had supplied air in the back.
Wow.
So I wasn't taking in anything but the air coming in. So, and you definitely have to have eye protection.
Oh yeah, I mean, especially even if it's not a gas, anything flammable, you want to protect your eyes. That's a great point.
Exactly.
This is Zalia Chester. She's a junior, and she asks, "Is there any part of this career where you've had something happen and made you second guess your choice?"
Yes. I've had a lot of long nights. I worked Christmas 2020. I was on the phone for 3 hours dealing with an issue. 1 year when I was at my first job, I was at a storage unit at 11:30 at night because we were contracted to come and clean a storage unit out that somebody had just let go, and it was full of chemicals. So we were in Little Rock, Arkansas at 11:30 at night. Had been on the job for about 12 hours cleaning this place out, find some high hazard stuff that we had to then gear up and stabilize. So that was a pretty rough night as well.
Wow. This is Catherine Johnson. She's a junior, and she asked, "Do you ever get nervous when you have to deal with chemicals and you don't know what they are?"
Yes, if you don't know what the chemicals are, you can either one of the things you can do is you can leave them because you can't identify.
Yeah.
You can try to categorize it by using what we called at the time a non-haz kit. So you would pH it, you would test to see if it was water reactive. Hopefully it's not air reactive when you open it up. So yeah, it's a nervous factor in regards to chemicals that you don't exactly know what they are, or you could just go ahead and try to high haz stabilize it, from the jump.
I just got two more from the students. This is Jasmine Williamson. She's a sophomore, and she asked, "Have you ever inhaled chemicals that affected your body?"
Thankfully, no. Thankfully, no, I have not. But I have been with people that got locked in. Well, they didn't get locked, but they were in a room, and a bottle of phenol got open, and so they got a little lightheaded behind that. So, thank goodness I haven't experienced that. But that is a risk and high hazard safety thing that you need to be worried about.
Yeah. Well, I just was handed another one, and this is a really good question because any type of engineering, the margin for error is so small. This is Brian McMurtry. He's a senior, and he asked, "How precise do you have to be on your chemical labeling?"
You want to be as precise as possible because if you're not even if you are the end result where you're stabilizing the chemicals for final processing, if it's going from you to somebody else for final processing, you have to be as precise as possible to let people know what's exactly in these bottles because there's different ways you treat different things. If you have an acidic chemical, versus a more basic caustic chemical, the way you're going to the pHs are all on the other end of the spectrum. So, you know, if you have an acidic chemical, you want to keep it with like acidic chemicals. If you have a caustic chemical, but you mislabel it and somebody put it with a caustic chemical and they react, well, basic chemistry, caustic and an acid make salt and water. But
Wow.
the byproduct that you don't hear about, there's a lot of heat that's exchanged in this process. So if you have a drum that's reacting with acids and basics in it, and then you have a lot of heat, I mean that's a recipe for disaster right there.
Wow. That just sounds scary. Man, the attention to detail is insane. This is my last one from students. This is Layla Young. She's a senior, our Miss Velma Jackson. And she asked, what led you to be what led you to focus on environmental engineering?
Okay, well, first off, congratulations, Miss Velma Jackson. Uh, what led me to doing environmental? So originally, being truthful, when I went into biological engineering, I still wanted to do something in the medical field. And so after my first year, I was like, yeah, I don't really know if I'm going to have enough brain power left after I get through engineering school to go into medical school. So I'm going to find something else that interests me. So I went to my advisor and we talked about a lot of the different paths that you can take in biological engineering. One of them was environmental. I always like being outside, played football, you know, did a lot of different things. So, you know, having a career outside didn't seem so bad. And so I got hooked into the environmental track of my engineering major. And, you know, it's all worked out. I've enjoyed it. You know, I've done a lot of cool things with my job. I've got to go to a lot of different places. You know, I worked on Katrina and the BP oil spill, two events that are going to go down in history, and I was boots on the ground. So um, it's been a tremendous opportunity that I've really enjoyed.
Yeah, that is awesome. And I agree. That's two tragedies that you really got to make a difference in helping the community be safer and healthier. I can't talk. Now we're almost out of time, and we thank you so much for joining us. But before we go, we'd be remiss now with this being the first day of Black History Month to understand the role that young Black kids can have in this field, because obviously there's always a need for them. There's a need to diversify. And there's a big movement to diversify engineering. And I know you were a member of NESB at Mississippi State, which is a great organization. They have them at PWIs and HBCUs. But what can these young people do to follow in footsteps like you? Because, like I said, we're both old. We're about the same age, and environmental engineering needs these kids. So why should they look into this, and why does engineering need them?
Diversity of thought. You know, everybody talks about diversity. Everybody talks about, you know, the need for it, but you know, the diversity of thought to be able to come in with your specific and background, your specific experience, you're going to look at a problem totally different than somebody else who may not be, you know, a minority. One of the things that I think is helpful is when there are environmental justice issues, people with a diverse background, you know, they get to look at this from maybe even a lived experience. Maybe they grew up, you know, in a situation where it directly impacted them and it wasn't just something that they read about.
Yeah, that was
Um,
recently in Jackson with that had the garbage dumped by was by the airport where people lived. So that is a
yep.
great point.
Yeah, and it's things like that that I feel like, you know, as people of color, as young people of color, when you get into these fields, that you get a chance to make a difference, and it means that much more because
Absolutely.
maybe you've experienced it. And you know, I will say that it can be challenging sometimes when you go into a room and you're the only person that looks like you. But if if you know why you're there, if you know why everything's important to you, then that'll quickly, you know, subside, you know, itself. And that's probably been one of the most challenging things as far as being a minority in the engineering field. You know, ever since I've been in college for the most part, I'm in rooms where it's not a lot of people that look like me. But the one thing that I have learned is that, you know, you can make connections based on a lot of different things. You know, even something simple as college football has gotten me, you know, into conversations with people that I probably wouldn't have. And then, you know, once they get to know you and once they get, you know, to see your character, you're not just, the black guy, you know what I'm saying? No, that's Kyle, you know what I'm saying? So, I mean, and it makes a difference.
That's awesome.
And,
Well,
and the kids, that makes a difference, and you can make a difference. And that's why we need more of you all in the field.
absolutely. And because we aren't getting any younger. But again, thank you so much for taking some time for us today. It's always enlightening. Just so much cool stuff in that field that kind of gets overlooked. But really, for people, any young people wanting to get into a science-related engineering, environmental engineering is the way to go. Really cool stuff you're doing. So again, Kyle Sykes, right here in Jackson, Mississippi. Thank you so much for joining us.
Thank you so much for having me.
All right, talk to you soon, my friend.
All right.
See you.